In this video, we're going to take a look at question 9 from the day 1 homework, and this is from the practicing with triangles section from the CEMC OpenCourseWare stuff. So we are dealing with two ships underwater, and it tells us two ships with underwater, sorry, one ship is underwater, two ships are on the surface. It says we have two ships with underwater sonar detection equipment have located the wreckage of an old sailing ship on the sea floor. The wreck, W, is located at the bottom of a vertical plane, ABW. So basically you're imagining everything's in a single line, which passes through, so to make the question two-dimensional, which passes through the ships on the surface at points A and B. So let's draw our surface with ships A and B. And when the distance between A, B, and ship W is at the bottom. So we'll sketch ship W. When the distance between ships A and B is 6,000 meters, so let's label that right away, 6,000 meters. The angles of depression, so that's measured from the surface of the water looking down, are angle WAB, 73 degrees, so we go from W to A to B, and this angle right here is 73 degrees. And angle WBA, so W to B to A, let's tighten that up a little bit, W to B to A is going to be 41 degrees. Determine all possible values for the depth of the wrecked ship to the nearest meter. We'll find at least one possible value. So start off with your diagram, always a good idea. The next thing I notice is that I'm missing an angle, angle W, so that I can find it quite easily. So I'm just going to do 180 minus 73 minus 41. 73 minus 41 tells me that that missing value has a measure of 66 degrees. All right, so far so good. Next, I need to find the depth or the height, just like my previous triangle problems kind of. So I'm going to make a line straight from my shipwreck up to the surface, 90-degree intersection. And now I'm going to work with that right angle triangle right there. Call this point D just to be consistent with our previous questions. 90 degrees, point D, point A, point W, 73 degrees, and that is enough information for now. What I don't know is the length of AW. I'm going to need to find that, and in order to find that, I'm going to use my original triangle up here at the top, and I'm going to use sine law. So, because I know opposing sides of angles and side lengths, so sine 66 degrees over the opposite side of 6,000 is equal to, and I'm going to want to find this side right here, because that's the triangle that I've decided to work with. So, sine 40 is equal to sine 41 degrees over AW, which is the side length roughly. So I'm not going to show all my rearranging work, but we will rearrange and find that AW is equal to 6,000 times sine 41 degrees over sine 66 degrees. And we're going to find that AW has a length of sine of 6,000 times sine 41 divided by sine 66. So length of approximately 4,309 meters. Now that I know that value, I can carry it over to my other triangle here, and we'll indicate that this side length is 4,309. Let's add our trigonometric labels to this triangle and see if we can figure out some missing information. This is my height, or my depth, side H, and this is my angle of consideration here. Oops. So let's label according to that. Hypotenuse, opposite, adjacent. I know the hypotenuse, I want to find the opposite, so I'm going to use sine. Sine theta is O over H. Sine 73 degrees is O, is my height. H, we found, is my length AW, which is 4,309. So, height is 4,309 times sine 73 degrees. 0.4309 times sine 73 degrees gives us a depth or triangle height of approximately 4,120, actually 20.7, so we will round appropriately, 4,121 meters. So therefore, the depth of the wrecked ship is 4,121